VisualLogic is not AI-assisted programming, it's AI-native programming. Most tools today bolt AI onto code-first workflows. We're starting from the opposite premise. If AI is a first-class citizen, the programming foundation itself must be designed for AI. Here's our roadmap for today, covering 4 chapters. 1. The AI native shift and why code-first tools hit a ceiling. What VisualLogic actually is, language plus IDE AI designed as one system. 3. The core insight, VL as the intermediate representation. 4. The practical impact on cost, collaboration, and shipping speed. Welcome to VisualLogic. This is not just another coding tool or low-code platform, it's a complete reimagining of software development. Let me walk you through our 4 core innovations. Component-oriented. We simplify every app to just 3 elements: properties, methods, and events. Decoupled architecture. Separate layers for app, section, and service enable parallel AI generation. 10x faster generation. Because of our structure, multiple AI agents work simultaneously, delivering 10x speed at 90% lower token cost. Bidirectional IDE, real-time sync between code, visual, and logic views. Most AI programming tools today are still fundamentally code-first. Think about Cursor, Copilot, or Replit. They take existing languages like JavaScript or Python and add AI on top. We believe this is the wrong starting point. These languages were designed decades ago for humans to type manually. When you bolt AI onto these legacy foundations, you inherit all their complexity. Let me be clear about what VisualLogic is and is not. It is not a DSL like SQL or Terraform, which are limited to specific domains. It is not low-code like Bubble, where you hit a wall when complexity grows. VisualLogic is a new programming paradigm. It is a complete system where the language, the IDE, and the AI generation are designed together from day one. This is the VisualLogic IDE. It's not just a text editor. On the left, your files are organized by type, VDB, VSC. In the center, you have the stage for visual editing, synced instantly with the VL code view. On the right, the AI playground runs multi-agent generation with real-time cost tracking. When you see an error, you don't need to ask AI to fix it. You click it, jump to the visual editor, and fix it yourself in seconds. We are competing on fundamentals at 3 levels. Level 1, language. Traditional languages are syntax-heavy. VL is component-based. You learn one document and you're productive. Level 2, IDE. Traditional IDEs are text-based. Ours is bidirectional. The visual view is the code. Level 3, AI. Traditional tools generate line-by-line sequentially. VL uses multi-agent parallel generation. Here is the head-to-head comparison against AI-powered IDEs like Cursor and Replit. Generation mode. They use single agent sequentially. We use multi-agent parallel. Abstraction. They work at the line file level. We work at the component level. Visual editing. They have none or preview only. We have full bidirectional sync. Token cost. We are 10x cheaper because we don't generate boilerplate. Let's clarify the landscape. Low-code, no-code tools aim to hide complexity using templates. They are fast but inflexible. DSLs aim to solve one domain like SQL for data. VisualLogic's goal is to structure complexity. We are general purpose. You can build any full-stack application, but with a structure designed for AI. This is the essential difference. Low-code hides complexity. It makes decisions for you, which is why you eventually hit a wall and have to eject to code. VisualLogic structures complexity. We model the PME trinity explicitly. We don't hide the logic, we make it manageable for both humans and AI. The root problem is that current programming languages were not designed for AI. They assumed a human was reading millions of lines of documentation and managing implicit relationships. Now we force AI into this system. AI has to generate linear text line by line, dealing with hidden dependencies. This fundamental misalignment is why AI produces broken code and hallucinations. The industry faces a fundamental choice. Path 1, AI on top. Polish legacy systems like JS and Python. This is the industry standard. Path 2, AI native. Design a new language from scratch for the human plus AI's compiler era. This is our path. If AI is a first-class citizen, the language itself must be designed for it. The order matters. The industry starts with an existing language, uses an existing IDE, VS Code, and adds AI. Each step is constrained by the last. We built in the opposite order. First, a new language with AI-optimized structure. Then a visual IDE that projects that language. Finally, AI generation that leverages that structure. Now let's look at Chapter 2, VisualLogic as the representation layer. This is the technical heart of why our system scales. For a traditional full-stack app, AI must understand React docs, Node APIs, SQL syntax, CSS frameworks, and countless libraries, millions of lines of changing context. In VisualLogic, there is one source of truth, the Bible. The entire syntax is 127 keyling. AI only needs to understand this one document to master every aspect of development. Our design philosophy is remove syntax, preserve logic. Traditional languages are full of noise, boilerplate, imports, conventions. VisualLogic minimizes this. We use components as the atomic unit. Everything is explicit. The result is a language that is 100% logic and 0% noise. Every VisualLogic app follows a strict component-oriented architecture. An app is composed of layers: app, front-end, back-end, data. Every component is composed of just 3 elements: properties, data, methods, actions, and events, triggers. This consistency is what allows AI to generate complex apps reliably. We are moving from 1D to 2D programming. Traditional code is a linear stream of text where structure is implicit. VisualLogic is spatial. Components like header, auth, and database occupy their own space with explicit connections. You aren't just writing lines, you are assembling a multi-dimensional structure. Why is natural language to code so unstable? Because there is a gap between the ambiguity of make a to-do app and the precision required by code. With no stable intermediate structure, the AI has to guess. This leads to inconsistent output and hallucinations. It's not a model intelligence problem, it's a representation problem. VisualLogic solves this by acting as the intermediate representation. The chain becomes human intent, VisualLogic, the IR, executable code. Because VL is the IR, we control the entire pipeline, making the output verifiable and consistent. As an AI-native IR, VisualLogic has 3 key properties. Verifiable. You can check the structure before running it. Rewritable. AI can surgically rewrite just one component without regenerating the whole file. Compressible. It uses 90% fewer tokens to express the same logic. This is the strategic insight. Whoever controls the representation layer controls the system's ceiling. While others focus on bigger models, we focus on efficient representation. This is the bottleneck that matters as software scale grows. The industry thinks bigger models use better code, but the real bottleneck is representation complexity. VisualLogic solves code bloat, prompt instability, and context overflow at the foundation. Efficient IR enables sustainable scaling. Token cost is real economic cost. With traditional code, as your app grows, the context window explodes and costs become prohibitive, linear or exponential growth. With VisualLogic's compressed representation, cost grows much slower. This efficiency is a long-term economic moat. Chapter 3: Human plus AI Collaboration. How do we move from just generating code to actually working together? Have you experienced this? You ask AI for a button change, and it rewrites your whole component. Or it fixes a bug but breaks the structure. Or you and the AI keep creating merge conflicts. The root cause is that humans and AI are competing for the same lines of text. We solve this by collaborating at the component layer, not the text layer. Traditional collaboration causes conflicts because everyone edits the same file. In VL, the human works on the header component, while AI builds the auth component. Components are independent units, so merge conflicts are virtually eliminated. The new model is human architects, AI builds. The human focuses on the structure, relationships, and business logic. The AI focuses on generating the components and implementation details. We collaborate on structure, not text. We need to rethink the IDE. The traditional IDE is a historical artifact, a text editor with plugins designed for manual typing. Even with AI, it's still text-centric. Structure remains implicit. We are changing that. In VisualLogic, code and graph are just different projections of the same structure. Code view, precise control, version control friendly. Graphical view, intuitive navigation, visual debugging. They stay in real-time sync. You can understand the logic without ever learning the syntax. Chapter 4: Impact and Delivery. Let's look at the proof, the scaling, and the workflow. Why does AI love VisualLogic? Traditional, AI generates sequentially, line by line, wasting tokens on imports and boilerplate. VisualLogic, AI generates the program structure, visual view, and executable code simultaneously. One line of VL equals 200 to 400 lines of traditional code. Here is the proof. On the left, a VL section, 10 lines of pure logic. On the right, the equivalent React plus TypeScript, 100 plus lines of imports, interfaces, and styling. This represents 90% less code and 90% token savings for the exact same functionality. This isn't just for demos. All backend infrastructure is abstracted as components. Database, message queues, Redis, sockets, cloud runtime, everything is available as a component. You can build scalable full-stack enterprise applications from day one. You have zero backend ops, but full choice. Cloud deploy, one click to our cloud. Auto-scaling, zero maintenance. Self-host, export the compiled source code. Deploy it to your own infrastructure. You maintain full data sovereignty and control. This enables vibe coding, the best of both worlds. AI chat, describe your vision. AI generates the full scaffold UI logic in seconds. Visual IDE, refine the details manually, pixel-perfect control without waiting for AI. Deploy, ship immediately. VisualLogic is not AI-assisted programming. It is AI-native programming. We designed the language, the IDE, and the collaboration model specifically for this era. And this is just the beginning. VisualLogic.ai